Hello everyone, today in this video we are going to talk about motion and speed. So after this video you should be able to define rest and motion and derive and apply the formula of speed. Suppose we are considering a clock and a car. So with the passage of time the position of this car is not changing, so that means this car is at rest. So we say an object is at rest if its position is not changing with time. But if you consider a next car, you can see its background is changing, that means its position is changing with passage of time, so we can call it in motion. So an object is in motion if its position changes with time. Now next I'll show you a video to give you the idea of motion.
It's not clean. Tunnel ahead. I'm gonna lose them.
So in the video you have seen lots of things moving. Now we'll see the same video. Now in this video the camera is on train, so you can see two men fighting in rest and other things like tree and all, they move backward. So now in next video when the camera is outside, we'll see these two men moving with the train.
Tunnel ahead. I'm gonna lose them.
Now let's talk about the state of motion of this guy. So if you ask this guy what was the state of motion of this guy, he would say he was at rest because he was fighting with him in the same train, so he may say he was at rest. And if you ask her what was the state of motion of this guy, then she may say he was moving with the train, that means he was in motion. So the same person is at rest for one person and he is in motion for another person. So why is this happening? So the answer to this question is motion and rest are relative, so they depend on each other. So like state of motion of an object depends on the state of motion of the observer. If the observer is moving with the object, then he may see the object at rest. So these are the types of motion. So we have one dimensional, two dimensional and three dimensional motion. In one dimensional motion we need only one coordinate to find the position of the object. So in this picture you can see we just need x-axis to find the position of the ant. If this ant is moving on a piece of paper, then we need two dimension to find the position. First we have to go this much distance in along x-axis, and then we have to go this much distance in y direction, then only we'll find the position of this ant. Now in third case this bee is flying in a three-dimensional space, so to get the position of that bee we have to have x-axis, so we have to walk towards x-axis, then we have to go towards y-axis, then we have z-axis also, that means the height. So after going to some height, then only we'll find the position of the bee. So we out here we need three dimensions. So this is one dimensional, two dimensional and three dimensional motion. Now suppose you are going from point A to point B. So first you are taking this path. Suppose in second case you are going through this path, which is a little longer than the previous one and the distance is 90 km, and in first case the distance was 45 km, and in third case you are taking another path and the distance is 140 km. Suppose in fourth case you are taking a helicopter to reach the point B, so you are going straight, the distance is 20 kilometer. So all this number out here is representing the distance, and the shortest distance between A and B is called displacement, and the shortest distance is always a straight line, and the length of the path is called the distance. Now let's understand distance and displacement through an example. So distance is the length of the path and displacement is the shortest distance between initial and final position. That means final position minus initial position. So in first case the car is going from 0 to 3. So distance is length of the path, that is 1 plus 1 plus 1, that is 3 meter, and displacement is 3 meters minus 0 meter, final position minus initial position, so that is 3 meter. So in case 2, suppose this car is going from 0 to 5 and coming back to 3. So now the distance, I have to add the length of the path. So while going it has covered 5 and while coming back 2, so this is 7 meter, and the displacement is towards the right it has covered 5 and towards the left, which is negative, it has covered 2, or you can say the final position minus initial position. So it is again final position is 3, initial is 0, so 3 meter. So out here distance is 7 meter and displacement is 3 meter. In third case it is starting from 3 and coming back to 3. So distance is while going to while coming to, so this is 4 meter, and displacement is while going to and while returning it will be considered as negative, so plus 2 minus 2 is 0. So if you take initial position minus final position, so final position is 3 and initial position is also 3, so it is 0. Now case number 4. In this example this car is starting from 4 going to 5 and back to 2. So now the distance is 2 plus 2 4, and the displacement is, we are going 1 meter towards right, that is positive 1, and 3 meter back, so that means plus 1 minus 3 is minus 2. And if you take the initial position and final position, initial position is 4 meter and final position is 2 meter, so 2 minus 4 is minus 2 meter. So if you see out here all the distance, then it is positive and non-zero, but if you see the displacement, some are positive, some are negative, some are 0. So displacement can be positive, negative or 0, but distance is always positive and non-zero. So these are the differences between distance and displacement. So distance is the length of the path and the displacement is the shortest distance between initial and final position, and distance is scalar and displacement is vector. Vector means any quantity which have direction and magnitude and it obeys the law of vector addition. If a body is moving, then it cannot have zero distance, but a body which is moving can have zero displacement. And these other parts we have already discussed. You can pause the video and read by yourself. So this is the distance time graph. So this is for uniform speed, this is for non-uniform speed, and this is for stationary objects. So distance is not changing with time. Out here the distance is uniformly changing with time, and out here it is changing non-uniformly. Slope of distance time graph determines the speed. Steeper the slope, more the speed. So out here in ABC, A has the highest speed because it has got steepest slope. These are the distance time graph, which is not possible. Out here you can see distance is decreasing with time. So but we know distance of a moving object never decreases, only displacement can decrease. Out here in one time we have many position of the object, so this is also not possible. So suppose this is 5 seconds, at 5 seconds the object is present at 1 meter also, 2 meter also, 3 meter, 5 meter. So it is not possible for an object to be at many places at the same time. Out here also, if you consider this time, at this time the object is present at 2 places, which is not possible. Distance can be greater than displacement, or it can be equal to displacement when the object is moving in a straight line, but displacement can never be greater than distance. Distance can never be negative or 0, but displacement can be 0 or negative. So for 2 points we have only one displacement, that is a straight line between them. And for a moving particle, distance can never decrease, but displacement can decrease. Speed gives us the idea of how fast the object is moving. So, and the definition of speed is rate of distance covered per unit time. It is a scalar quantity. Dimension is length 1, time minus 1, and unit is meter per second, and in CGS we can say centimeter per second. This is the formula. Speed is change in distance by change in time. So change in distance we denote by delta S. So S is the symbol for distance or displacement. So, and this delta means change. And average speed is total distance by total time. So let's consider the previous case. Suppose you are going from point A to point B. At this time your average speed is total distance, that is 45 km by 2 hours. So 45 by 2, that means 22.5 km per hour. So the average speed of the car is 22.5 km per hour. We got the average speed to be 22.5 km per hour, but the car do not move with the same speed throughout the path. So if you get a smooth road, you may speed up, and if you get the rough road, you may slow down. So the speed was not 22.5 throughout the path. So we have to have instantaneous speed. Instantaneous speed means speed at a particular time. It may be out here, it may be out here, it may be on the smooth road, or it may be on the rough road. So speed at a particular point is called the instantaneous speed. So this is the formula for speed, that is change in distance by change in time. And if you consider this time to be very small, like this, suppose delta t is very near to 0, like 1 second, 2 second, that time distance cover will be also small, and that time you will get the speed of this car at this point. We are not taking the average, but we are taking the speed at a particular time, that means in a certain place. So to get the instantaneous speed, we have to take limit to this time. So we have to make time very small. So out here you can see time is approaching 0, and I am taking the limit to the time. So limit delta t tends to 0 means it is not 0, but it is near to 0. And whenever we see this, so this is the rate of change. Delta s by delta t is rate of change of distance with time, and we are making it very small. That means it is the rate of change, and which is very small, that is differentiation. We know the differentiation is rate of change, and the rate of change is very small. If you differentiate distance with time, then we'll get the instantaneous speed. So now let's solve one question. So position of a particle is given by s is equal to 6t square plus 2t plus 4 meter, where t is in second. So out here it is saying that the displacement depends on time. So at different time we'll have different displacement or position. So we have to calculate the position of particle at 1 second and 5 second. We have to calculate the average speed between 0 second and 2 second, and we have to calculate the speed. When I say only speed, that is instantaneous speed at 5 second. So what is the speed of the object when the time is 5 seconds? So let's find the position of particle. So the equation for the position is this. So now in order to get the position at 1 second, I have to put the time. So I'll just write s1, meaning the position of the particle when time is 1 second. So if you put t is equal to 1, you will get 12 meters. So the object is at 12 meter when time is 1 second. So now let's see the position when it is 5 seconds. So same thing I'm doing. So I'm getting 164 meters. So at 5 seconds the position is 164 meter. So you can see out here how the position changes with time. So now we have to find the average speed between 0 second and 2 seconds. So position of the particle when time is 0 second is 4 meter, and position when time is 2 second is 32 meter. Now change in position is 32 minus 4, and change in time is 2 minus 0. So now we know for average velocity it is change in position by change in time. So you will get 14 meter per second. Now the last question, calculate the speed at 5 seconds, that is instantaneous speed at 5 seconds. So to get the instantaneous speed I have to differentiate the distance with respect to time. So ds upon dt, so I'm putting the equation of s. So differentiation of t square is 2t, differentiation of t is 1, and differentiation of constant is 0. So this is the equation for instantaneous speed. Now I want instantaneous speed at 5 seconds, so I'll put the value 5 out here. So v5 is equal to 62 meter per second is the instantaneous speed. So similarly you can try this question. Now next is velocity. Velocity is speed in a particular direction. So rate of change of displacement with time is called velocity, and the formulas are same as speed, and unit is also same. So we have different types of velocity. Uniform velocity. Uniform velocity means the velocity is not changing. That means the speed and the direction of an object is not changing. In non-uniform velocity, either speed or direction of the object changes. And average velocity is total displacement by total time, and instantaneous velocity is same as instantaneous speed. So it is the velocity at particular time. It can be found out by differentiating the displacement with respect to time. And the speed and velocity is almost same, only the speed is a scalar, velocity is the vector, and speed in a particular direction is called velocity. And we can change the velocity of an object either by changing the speed or by changing the direction of motion. So now let's summarize the video. So rest and motion are relative, and distance is the length of the path, and displacement is the shortest distance between initial and final position. And if you take a straight path between 2 points, that time distance and displacement is equal. And the speed gives you the idea how fast is the object moving, and the velocity gives the idea how fast an object is moving in a particular direction. And to get the instantaneous speed we have to differentiate the position with respect to time. So this is the end of the video. Don't forget to like the video and subscribe the channel. Thank you.